In part 1, we have derived the member force of these truss structures shown here. So we got all the member force and reaction force on this truss. So now we will continue to work on this problem to calculate the displacement at joint A. So once we got the member force of these truss structures, so we say this is a real systems because this is the node is actual node. So then we need to build up the virtual system for these truss structures. So let's move these real systems to here. So we have these real systems. We got this member force, reaction force shown here. So we see this is real systems, and here we have virtual systems. So this is virtual systems. For virtual system, because we need to know the displacement of joint A in vertical direction, so we need to apply a virtual unit node. So we see is 1. So we can put it as 1 kilonewton or 1, it doesn't matter. So then we need to come out the virtual member force of these virtual systems. So we can go through the same procedures, so process to calculate the reaction force and then calculate the member force. But here we don't need to go to that again because we find, so this is 5 kilonewton, this is 1, that is mean we can proportionally determine the member force by compare with the real system, because if this is 5 kilonewton, so the number AB is 6.25 kilonewton, that is mean AB is definitely 1/5 of this value. So we can easily come out the member force for the virtual system very quickly. So for is 6.25 here, then this will be 1.25. So here is 7.5 kilonewton. So here will be 1.5. And similarly, here is negative 1.25. Here is negative 2.75. So we're gonna more the member first. So positive, that is mean the member is in tension. Negative, that is mean the member is in compression. So then we need to apply the method of virtual work. We write down the equation of method of virtual work for the truss structure is shown here. So I21 to 4. So this is I. So small ni. So virtual member force, capital Ni, the dimension of the member L, and Young's modulus and the area of the member. Because we have a summation here, this involves 4 members and also involve many atoms, small ni, capital Ni. So the best practice that we build this system, we build this calculation in the table. So for this table, the first column is the member. It's a truss member. So truss member, we have AB, BC, BD, and AD. We have 4 truss member. The second column will be Ni. So it's virtual member force. Because we just apply 1 virtual force, so there's no unit for Ni. So I prefer this way. So small Ni. So for member AB, we got a force is 1. We got a force that is 1.25, and for BC we got 1.5. For BD is negative 1.25. For AD is negative 0.75. So this is the first column. So the second column is second column, small ni. The third column is capital Ni. This is the member force in the real system. The unit is kilonewton. So we can, for member AB is shown here. So it's, so put here 6.25 kilonewton. For member BC, right down here is 7.5. BD is negative 6.25 for the AD is negative 3.75. And then the upcoming column is the dimension of these members. We know for AB is 2.5 meters, here is 1.5 meters, 2.5, and 3 meters. So then the last column, we just adding them, plus them, multiply them together. We got this. So for this, for the first row, we got a value. So the unit will be kilonewton meter. So this is just this part. Okay. So we got the first row, the value. Once we calculate, go to the third digital. We got this value. Here is. So it's very straightforward. Just calculate this 3 for this 3 for this. So just like that. Got here is here the last one is 847,437. So we got small ni, capital NIL. The summation of these 4 will be 64.7374. So then once we got this value, so we can apply the equation here. So then the 1.ay equal to small ni over EA. And we know EA is a constant, so we can move out EA for small ni, capital NIL. Then is equal to, so we got E is, so E is 200 gigapascal, and the area is 600 millimeter square. So we got here E is 200 gigapascal times 10 go to the 9th and times the 200. So this is converted to the Young's modulus to Pascal. Here converted to the millimeter square to meter square. So we need this conversion to make the unit consistent. So here is 6. So the summation of this is going for 64,374 because the unit is kilonewton meter. So we need times 1000, and then the unit will be meter. So once we do calculation, we can come out result is 0.536 times 10 go to negative 3 meter. That is equal to 0.536 millimeter. So this is the vertical displacement at the joint A. Because this is positive, that is mean our assumption on the direction of the displacement is correct. What is our assumption? We assume the displacement direction is go downwards, okay, because we apply unit node 1 going downwards. So look here, so that means delta AY is equal to this value and the direction is go to downwards. So this is the whole procedure to using the method of virtual work to calculate the displacement of the joint A in vertical directions. Okay, so this is that. So that's all. Thank you very much.